All right, we're back. I was cut off, okay? I think we were talking to Sierra, how wide awake she looked, and she was saying to me, what? You had to walk the dog this morning? You should walk the dog more often.
I do. I have like 3 or 4 times a day.
Excellent, excellent. I like that. Okay, now, so let's talk about ions. All right, now. This is what happens. Are you ready? You ready? Now. Neon. Write this down. Neon has two electrons in the first shell. That's made of the 1s, right? Yes? And then you have in the second shell, which is an S and P, you have 8 electrons, right? Yes?
Yes.
Now, can you see, I'm going to do a check, okay? Excellent. So this is we'll call this N for nucleus, okay? So this is neon. All right? Yes? Now, let's look at sodium, okay? Sodium, all right? We'll write and we're going to do okay, then we're going to put in the electrons. It has how many in the first shell? Sodium.
2.
And it's just a 1s, right? This is N for nucleus. How many in the second shell?
8.
8, because you have 2s2, 2p6, right? The long form electron configuration for sodium is 1s2, 2s2, 2p6 so far, right? So I've got to put 8, right?
Yeah.
Okay. Is that okay? Are there more electrons for sodium?
Yes.
And what's the end of the electron configuration? 3s. Tilly? 3s1? Yes? Okay. Okay. This is what happens. Are you ready? Are you ready? You ready?
Yeah.
Are you ready?
Yeah.
Evil laugh, huh? Okay, this is what happens. You ready? Write this down. This is cool stuff. All elements react. Write that down. All elements react to be like the nearest noble gas. All right? Next sentence. Next sentence. All elements react to be like the nearest noble gas. All elements react to be like the nearest noble gas. All elements react to be like the nearest noble gas. Say it with me. All elements react to be like the noble gas. Louder. All elements react to be like the noble gas. Louder. All elements react to be like the noble gas. Louder. All elements react to be like the nearest noble gas. Easy? Okay. The elements, outer shell, the elements' outer shell, after they react, will be, the elements, after they react, will have, did I say will be?
Yeah.
I meant will have, the elements after they react will have a valence shell exactly, will have a valence shell exactly, will have a valence shell exactly like the nearest noble gas. Okay? You get that? So far so good? Yes? What did I say? Okay, you get that? The outer shell of the elements after they react will have a valence shell just like the nearest noble gas? Is that about right? Yes?
Yeah.
Yes? Okay. So, what happens is this. Let me make another one, okay? This is chlorine, okay? Nucleus. Where's chlorine on the periodic table? What column? 1 through 18, what column?
17.
17. Right here?
No.
No?
Oh, group 3.
That one? That one, right, yeah, that's chlorine. This is sodium. Right? Okay. How many, let's write the long form electron configuration for chlorine. Okay? Where can I write that? Can I fit it right there? Can you see on the film? Is right there is okay? 1s2, is that coming up? Yeah. 1s2, what's next?
3p5.
Yes? You okay with that? All right? Yes? Yeah. Let's draw, okay, so how many electrons does it have in the first shell? 2. In the second shell?
8.
In the third shell?
7.
2 plus 5 is 7. Okay, you all right with that? Yes? Okay. Let me draw one more shell. I need to do a check. I don't have a videographer here. Just a second. Excellent. Okay. I'll make one right here. I'm going to make another one. Okay. Okay. Argon. Argon. What's the electron configuration for argon? 1s2, that's the first shell, right? Isn't that 1s2? Putting 2 electrons there. Shall I do the electron configuration right here? 1s2, this is for argon. 1s2, 2s2, 2p6. What's next? 3s2, 3p6. So in the second shell, it has
8.
right? 8, right? In the third shell, it has how many?
8.
8. No? Yes, 8. It does have 8, right? Okay? You all right with that? I'm almost there, guys. I'm almost there. Okay? Okay? All right, now. What happens when something reacts is simply like this. Are you ready? It either gets rid of an electron or gains an electron to be like the nearest noble gas. Isn't that what we've been saying all along? So sodium will go like this. Never mind if this is covalent or ionic, it doesn't matter. We're not talking about ionic or covalent bonds. Okay? We're not talking about ionic and covalent. We're just talking about when something reacts, what's its outer shell look like after it reacts. Understood? That's all we're talking about. We're not talking about bonds. Clear? Yes? And the word ion just simply means what? A charged atom. That's all the word ion means. It just means an atom with a charge. That's all it means. So we're not talking about ionic bonding. We're not talking about covalent bonding. We're not talking about molecular bond theory. We're not talking about orbital bond theory. We're talking about nothing. We're talking about simply an element reacts to be like the nearest noble gas, and what does that mean? That's all we're talking about. Okay, Greta? You with me? Excellent. By the way, Greta loves my videos. I want you to know that. We got 5 stars on my videos? 4.5 at least? 4.5, she says 4.5 stars. Oscar nomination, you think, in the future? Maybe? Excellent. Okay, so this is what's going to happen. Are you ready? We'll do this in black. Okay? Now let's do blue. We're going to go wild. We're going to do blue. You excited, aren't you? Okay. This is sodium right here, right? Sodium. See this electron here? It's going to go there. You see this? That's it. We're done. We're done. See that? That's it. That's it. That's it. Is that cool? They're asking, what did he do? What's it? Well, let me show you. That electron's gone, right? That electron's gone? Yes? Okay. Can I get rid of this blue thing? Is that okay? Right, there's the electron. So I can get rid of this, right? Is this still sodium? Yes, it's still sodium because it has how many protons? 11. And what defines an element as being an element? The number of protons. They remembered that. Excellent, right? So it still has 11 protons, right? Yes? Well, look at the valence shell. Doesn't it look an awful lot like neon? Yes? What's its valence shell now? 2, the second shell, right? Yes? 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 Okay. Okay. Now look at chlorine. This is chlorine. Where's chlorine? Here. Can I get rid of this? Look at chlorine. Doesn't it look an awful lot like that? Right? You see that? Chlorine. It's now how many electrons in the valence shell? The same number as argon, right? So look what happened. Chlorine, this is argon. This is neon. Didn't chlorine gain one to be like argon? Didn't sodium give one up to be like neon? Isn't the closest noble gas to sodium neon? Isn't the closest noble gas to chlorine argon? Didn't sodium react to be like neon by giving up an electron? Yes or no? Okay. This is group 1, 2, 3 through 12, 13 through 18, right? That's the way we number groups now. Yes? Okay. So, valence electrons are just S and P only. So I can erase some of this stuff, right? May I? Okay. I'm going to erase this. I'm going to erase this. Okay? Now, I want to do long form electron configuration for sodium after it reacts. Okay? After it reacts. What's the charge of sodium after it reacts? Positive. Why? Why positive 1? Why does sodium have a positive 1 charge? Why is that? Yes?
Because it loses a negative charge.
It loses a negative charge. So how many positive charges does it have after it reacts?
It has 11.
It has 11 positive charges. Excellent. Now this is a question before we continue. Alyssa, can you add? Can you add? You can't add? It's a shocking, I know, she's shocked by the question. Like, what does this mean? It's too easy of a question, right? She's got, you know what her reaction was? No, what? Oh, you get it now, right? You can add, right? Yes? Okay, good. Can you add negative numbers and positive numbers? Is that okay? Can I give you guys a problem? See if they can do it? Yes? Is that all right? Okay. Positive 18 plus a negative 9. Positive 9, right? You got to say positive 9. You just can't say 9, right? You all right with that? Give you one more? Is that all right? Positive 27 and a negative 30.
Negative 3.
Negative 3. Excellent. So you can add, right?
Yeah.
You were shocked by the question, weren't you?
Yes.
Excellent. But you know what I mean, right? Okay, excellent. So sodium has plus 11 because of protons, right? And how many electrons does it have after it reacts? How many electrons does it have after it reacts? How many electrons does sodium have after it gives one up and it reacts?
10.
10. Let's go back and review something. There may be something you forget. Ground state. Ground state is the state an atom is before it reacts. Ground state. Ground state means equal number of protons and electrons. Okay with that now? You forgot that? Ground state, equal number of protons and electrons. It's the unreacted state. So, sodium reacts. How many electrons does it have left over? Well, it had 11. It gave up 1. You guys said you can count. Count. Has 10, right? So plus 11 from the protons, plus minus 10 for the electrons. What's the charge? Okay. This is the long form electron configuration for sodium plus 1. Are you ready? Can I just do it? This is ground state neon. You see the similarity? You see that? Can I erase this down here for a minute? Can I erase just this? So, ground state. Sodium. 11 protons, 11 electrons, charge in the ground state is, what's the charge in the ground state? If it has 11 positive charges and 11 negative charges, what is plus 11 plus a negative 11? 0. You told me you can add, right? Are you sure you can add? What is the ground state of any atom? Equal to 0. Okay? Charge of 0. Okay? Is that all right? Now, over here, it has 11 protons. This is sodium. This is reacted. Sodium. Reacted. 11 protons, 10 electrons, charge, plus 1. Is that on the board? Did you get that? Yes, that's going to be there. Okay? So far, so good? Yes? Sodium is plus 1, right? Yes? Okay. I'm almost done. I'm almost done. Let's do chlorine. What's the charge of chlorine after it reacts? What's the charge of chlorine in the ground state first? 0. How many electrons does it gain or lose? 1. Gain or lose? 1 gain, right? How many protons does chlorine have always? 17. So chlorine has plus 17, right? How many electrons does it have after it reacts? 18 plus negative 18 electrons, right? What's the charge? Minus 1, right? So this is chlorine minus 1. Okay, can I erase this? Okay, here we go. You ready? You ready? 1s2, 2s2, 2p, 6, 3s2. Finish it. after it reacts? What's its electron configuration? Go ahead, finish it. 3p6, right? Right? Because didn't it gain an electron? It was 3p5, but it gained an electron, right? Okay, let's look at argon. 1s2, 2s2, 2p6, 3s2, 3p6. Same. You get it? You starting to get this? Yes? Yes? Okay. So let me ask you this. We went through all of this just for sodium and chlorine. Aren't you exhausted? How do we do this quickly? You can do the short form, but just listen to my logic, okay? Listen to my logic, okay? Yes? Doesn't each of these elements here, forget hydrogen, long story, but don't each of these ions here, atoms here, have a nearest noble gas? Yes? The nearest noble gas to lithium is helium. Sodium, neon. What's that? Potassium, argon, etc., right? Aren't all of these going to lose one electron to be stable? So what's this charge? What's the charge of everything in that column? +1. Yes? Here you have sodium, magnesium. How many electrons does that have in its outer shell? Remember, just the S and P just 2, right? Right? 3s2, right? So do you see how that's going to give up those 2 electrons to be stable? If it gives up 2 electrons, how many electrons will it have left over?
2.
No. Let's see. You guys are a little confused here with ground state. Ground state means protons and electrons are equal, right? Protons is the atomic number, right? What's the atomic number of magnesium? 12. So how many protons does it have? 12. How many electrons does it have in the ground state? 12. If it gives up 2, how many does it have left over?
10.
What element has 10 electrons in its ground state and it's stable? Neon. So what do you think the charge of magnesium is going to be after it gives up 2 negative charges? +2. Do you think that all elements in that column are going to be +2? Yes. Now remember, we're just talking about S and P electrons, right? Yes? These are D, so we're not going to talk about those. What's this? What element is right there? Right there. Boron is above it, and this is aluminum. Aluminium. How many people say aluminium? Raise your hand. Okay? It's weird. It's okay. I don't think you're weird. It's weird. I know. I say aluminum. People say aluminium. Weird. I know. Americans in British English and American English. Okay. Right? You ready? Yeah? Okay. So, how many electrons in its valence shell for aluminum? What's the short form for aluminum? What's the short form? Neon and then neon and then 3s2, 3p1, right? So how many electrons are in the S and P's? Remember I said S and P are the valence electrons, right? S and P, valence electrons. So how many S and P electrons does it have in the valence shell for aluminum?
13.
No? 3, right? Right? How many electrons in the valence shell for aluminum? 3. So do you think it's going to give up 3 to be like neon or gain 5 to be like argon? What do you think? It's going to give up 3. What's its charge going to be when it gives up 3 negative charges? It has 13 protons, and how many electrons does it have after it reacts? 10. So a positive 13 and a negative 10 is what? Positive 3. The whole column is going to be +3. Right? What about carbon? Is carbon going to give up 4 to be like neon, or is it going to gain 4 to be like argon? It could go either way. Yeah, it can go either way. For instance, if it's positive, we'll do carbon. Carbon's a little weird. It can go, that means that it gave up 4 electrons. That's called carbon disulfide. Stinky gas. Terrible. You know rotten egg smell? That's the other one. Terrible. Okay? Or calcium carbide. The miners, when they used to do mining before electricity and batteries and those sorts of things, the miners used to use calcium carbide. You put a little calcium carbide in a lamp, put water in it, and it produces acetylene. Acetylene is the most powerful gas that occurs in nature. Acetylene. Yeah? Very energetic. Okay? And the acetylene is produced, that plus water is acetylene, and then you put a little light there, and then the gas burns, and you can see. Okay? So that's plus 4, that's minus 4. See? So carbon can go either way. All right? All right? Yes?
Is that a poisonous gas?
It's a poisonous gas. Acetylene is not something you want to eat, drink, or be near, unless you have a lot of safety precautions. All right? So, let's continue. So this is going to be plus 4, minus 4. What about these elements? Are they going to give up? Are they going to give up 5 or take on 3? What do you think the odds are? Take on 3. So what's their charge going to be? Minus what? Minus 3, right? Minus 2, minus 1. Easy? Yes? And how do you name them? How do you name them? How do you name them? Well, the positive elements, listen carefully. The positive elements is just element. In other words, sodium ion. That's all you do. Okay? Sodium ion. Yes? You get it? Yes? Okay. And the negative, you say the suffix IDE. What's a suffix? What's a suffix? The ending to a word. All right, so I'll give you an example. Chlorine, -1. How would you name it? Chloride. Chloride. That's how you do this. Now you know, how many elements do you know now? 1, 2, 3, 4, 5, 6, 7, right? Plus 6 is 13, okay? And then all of these. You get that? Do you understand? Yes? We're off. Okay? We'll come back in a minute, okay?